Okay.
Assalamu
Salam.
alaikum wa rahmatullahi wa barakatuh. My name is Daniel Matthews. This is, of course, the voice of the Cape Matric Revision Programme. Today's lesson, of course, being mathematics. As you can see on the screen, we have with us here Mr. Muntasir Kadri, BSc Chemistry and private tutor at Intune. Assalamu alaikum wa rahmatullahi wa barakatuh to you, Muntasir. How are you doing?
Wa alaikum salam. I'm fine, alhamdulillah. How are you doing?
It's good. It's good. The weather isn't that bad. Alhamdulillah. It's not that cold. It's not that warm. It's just there. Just there.
Just,
So
just
there's
right
nothing
there.
to complain. There's
That's
nothing to complain about.
a Goldilocks scenario.
Truly. But anyway, brother, enough of me talking. You may proceed.
Okay, shukran. Okay, assalamu alaikum, everybody. So today we'll be looking at mathematics, specifically number patterns. This, of course, includes sequences and series. And we will just go through a few examples that students may struggle with, and hopefully this will assist you in the matter. So let us commence. As we see here, the first question is from a November 2020 paper. And the first question states that 7, x, y, negative 11 is an arithmetic sequence. Determine the values of x and y. So the important thing to identify is that they're telling us that this is an arithmetic sequence. So therefore, we should only be having a single difference, right? So if I take this, let me just add this to a new page, and we look at this over here. It's something important to note about this is if I rewrite this 7x, y, and negative 11, we note that this is the first term, this is the second term in the sequence, third term, and fourth term. Now, something interesting to note, for arithmetic sequences, right, you have the value of your first term, which is called the a value, right? So this would be our a value. And then the difference between x and 7 is your difference, d, okay? Now, if we look at this, we can go, okay, we have the number 7. We can say that the number 7 is just equal to a, right? And then we can state that term 2 is equal to a plus the difference, okay? Our term 3 is equal to a plus 2 times the difference. And if you think about it, it makes sense because we're just saying a plus d, which is equal to 2d. And then the fourth term is equal to a plus 3 times the difference. So what we want to do here is we want to somehow find what the difference is. So if you look here, we have the value for term 4. So I can go ahead and I can take this one over here, and I can use this equation and say, okay, if term 4 is equal to negative 11 and a is equal to 7 plus 3d. Now note how easy it is to find the difference. We just rearrange this equation, we do some algebraic manipulation, and we'll get 3d is equal to negative 18. And here we find that d is then equal to negative 6. Okay, so now we have the difference. So we can go ahead and find term 2 and term 3 with this difference, because term 2 essentially equals x, and term 3 essentially equals y. So I can go ahead over here and I can rewrite it as, okay, x is then equal to 7 minus 6, because the difference is minus 6, and we get the answer of 1. And then for y, we can say this is equal to 7. Oh, my apologies, I made a slight error. I forgot this is the second term. Sorry. It's x is equal to, no, sorry, I did the right thing. A plus d, yes. A plus d, which is equal to 7 minus 6, which is equal to 1. And then we do the same thing for y. Y is equal to a plus 2d. And this is going to be equal to 7 plus 2 times by negative 6, which is equal to 7 minus 12, which is equal to negative 5. And there we find that our sequence is basically 7, 1, minus 5, and negative 11. So something important to note about arithmetic sequences, they only have one difference. Whereas if you move on to a quadratic sequence, you'll have something known as a second difference. Okay, and that's how you solve this first problem. Fairly simple, not too hard at all. Just some things you need to remember is this, and we'll make a little important note here on the side. Arithmetic, right? They only have one difference. Right? That's about it. And then they will take the form of like term 1 equals a plus d, and term 2 equals a plus, term 2, my apologies, is equal to a plus d. Term 3 will equal a plus 2d, and we carry on so on and so on. And your a value just represents the first term in the sequence. Now, let's look at the next question. The next question is 2.2. Given the quadratic number pattern, -3, 6, 27, 60, they want us to determine the general pattern in the form Tn equals an squared plus bn plus c. So before we even jump into this question, let's just cover some knowledge on quadratic sequences. So if I scroll down here, and I'll show you quickly. Yeah, this is what I wanted to show you. I'll go in, I'll zoom in on this. And here they give us the general formula for the nth term of any quadratic sequence, where Tn, where that's the value of the term, is equal to an squared plus bn plus c. Now note, here's Tn. This is the first term. It's a plus b plus c. Here's the second term. Here's the third term. And here's the fourth term. Notice always plus c. C is just a constant. That's all it is. And that constant will remain the same, and it's unaffected by the number of the term. Right? But we can see here that n is equal to 1. So if the general form is an squared plus bn plus c, we can see, oh, if n was 1, this would just be a. If n is 1 over here, this would just be b. Hence why this is a plus b plus c. N equals 2. 2 to the power of 2 is 4. That's why they have 4 over here. 2 times b is 2b. That's why they have 2b over here, and then plus c, and so on and so on. This is how it carries on, okay? Then they show us here that the first difference is 3a plus b. Okay? And you can work that out by just subtracting 4a plus 2b plus c from a plus b plus c, and that will give us 3a plus b. The same for these first differences over here. Okay? And then we'll find that the second difference is common. It's consistent. It's the same second difference for each one, for a quadratic sequence, and it'll just be 2a, 2a. Right? Now, if you ever, what you could do, you could just remember this diagonal over here. If you remember this diagonal, a plus b plus c for Tn, first difference 3a plus b, and second difference 2a, you are already halfway there to figuring out your answer. However, if you do forget it, you can just do what I showed you, where you can derive it from the equation. You can actually derive this information from this equation, as we just looked at it here, how they derived it. Right? Now, let's jump into the question, because we're going to need this information to solve the problem. Now, let's go back here. So, they state here, given this quadratic number pattern, determine the general term of the pattern in form Tn equals an squared plus bn plus c. So, let us grab this question quickly, add it to a new page, and we'll take a little look at it. And let me just make this a little bit smaller. There we go, so I can have some space to work with. All right. So, they want us to determine the general term of the pattern in this form. And now let's go ahead and take a look. So, we write down our sequence. -3, 6, 27, 60. Okay, now this is our first term. I always like to head it because sometimes students forget what the terms represent. Okay, there's term 1, term 2, term 3, terms 4. Now the first one is we're going to find our first difference. So our first difference here, remember, your difference is always equal to T2 minus T1. or it could be T3 minus T2, or T4 minus T3. So we're going to go ahead and find them. So the first difference, 6 minus minus 3, is going to be equal to 9. All right? And we can take a look over here. 6 minus minus 3. Be very careful with this. Often students forget about how important the operators are, and they don't end up multiplying them together. Right? We know a negative times a negative gives us a positive, so this is going to be 9. So there we've discovered our first difference is 9. Now, the first difference between term 3 and term 2 is 27 minus 6. That's 21. And we go over here, and we'll find the first difference between 60 and 27 is going to be 33. Now we find the second difference. So here we go. Second difference. (21 minus 9 is going to give us 12. And 33 minus 21 is 12. And there we go. We see we have a consistent second difference of 12. Now we need to find the general form. Now remember, I showed you earlier that this values over here, which are the terms, are basically A plus B plus C. Okay. Here we have this over here, and we know that this is supposed to be 3A plus B, and this here is just supposed to be, let me just double check, I believe it's 2A, and there we go, 2A is correct, right? And here we go, 2A for the second difference. Now we can go ahead and find the value for A. I'll just clear this off, and I'll write it on the side over here. So 2A is equal to 12. Therefore, A is equal to 6. Okay, here we can say 3A plus B is equal to 9. We substitute the where we found our A value into this equation, so we can get B to be the only variable that exists, and that'll help us solve for B. So now we're going to get 3 times 6 plus B is equal to 9. This is going to be 18 plus B equals 9. Therefore, B is equal to, if we're going to move the 18 over, it becomes negative 18. 9 minus 18 is negative 9. And now we need to find C. So we have B, we have A. So here we can say in the next part, A plus B plus C is equal to negative 3. We substitute this in. 6 minus 9 plus C is equal to negative 3. Here we get negative 3 plus C is equal to negative 3, and therefore C is going to be equal to 0. So now we have our values. We know A is equal to 6, B is equal to negative 9, and C is equal to 0. Now what do we do with these? Well, it's fairly simple. They give us the general formula. So all we do is where we see A, we substitute the A value. Where we see B, we substitute the B value. And where we see C, we substitute the C value. So I'll go over here and we just go, okay, well, therefore the general formula for this is going to be Tn equals 6n squared minus 9n plus 0. And our final answer is 6n squared minus 9n. And that there is the general formula for this quadratic number pattern. Okay, so now we have the general formula. So let me just clear this off. Now, for the second question, they say calculate the value of the 50th term of the number pattern. So they're saying that n is equal to 50. So wherever you see n, you replace it with the number 50, and you substitute it into the equation we found in 2.2.1. So remember, often in mathematics, the next question you see is a follow-up question from the previous question. They all link into each other. So let us take a look and see what we come up with. Now we can go here and we can just substitute it in. So I'll use this equation and I'll just say T50 is equal to 6 times 50 to the power of 2 minus n times 50. And if I plug this information in my calculator, 50 squared, oh no, it's 20, 50 squared is equal to 2,500. We times that by 6, we get a value of 15,000 over here. And we subtract that from 9 times 50, which is 450. And we'll find that our answer will simply be 15,000 minus 450, 14,550. And there we go. We have solved the first one, and we have solved the second one. Okay, now on to the next question. Now remember, this is a quadratic sequence, right? Bear that in mind. We have not forgotten that. In the third part, they say, show that the sum of the first n differences of this pattern can be given by Sn equals 6n squared plus 3n. Now, there's a specific formula that will be on your formula sheets that will apply only to quadratic sequences when you are finding the sum of a quadratic sequence. Now, if we take a look over here, let me just zoom out and I'll show you where this appears. I just need to zoom out further. Sorry about that. Okay, so it's not showing here, but what I'll do is I'll pull up the memo and we can just actually compare it quickly. We can see that we derived our values correctly. Y was -5, x was 1, which was correct. We got the correct geometric formula, quadratic formula as well. And we also got the correct value, 14,550. Now, if we look here they show 2.2.3. We got 9, 21, 33, right? And here, oh, hold on, give me a second. Is that a different question? Sorry about this. I just need to check something. Yeah, that's correct. That's correct. That's all right. Okay. So, show that the sum of the first differences of this pattern. Okay. So, if we go back here to the board, here's our first differences. 9, 21, and 33. Right? We made a note of that. Show that the sum of the first differences of this pattern can be given by this equation. Now, let's see what we did. I got 9, 21, and 33 like we do over here. And if we take a look here, they used 9 as the first term of the first difference, right? And d is equal to 12. Now, here's the important part. Sn equals n over 2, 2a plus bracket n minus 1 times d. This is the formula you will use when finding the sum of a quadratic sequence. Right? This is the formula we're going to use. And then all we do is basically I'll zoom in a bit more, sorry. All we'll do is we'll just substitute the value of a, which is 9, which is the first term in the difference, which is the first term in that difference sequence that we found. We substitute it here into a, plus n minus 1. Now, we don't place any value into n because we're trying to find the general formula which represents the sum of those sequence of the differences, right? Because we want it to the nth term. And then the second difference was 12, so we substitute 12 into here. And then we just go, oh, well, 2 times 9 is 18. N times 12 is 12n. Negative 1 times 12 is negative 12. We then simplify this term in the brackets and we end up with 12n plus 6. And then all we do is we multiply and we expand this bracket. So n over 2 times 12n is going to give us 6n squared plus 3n, right? Fairly easy, fairly simple, okay? It is a bit of a tricky question if you look at it, because I always missed this important part here where they stated first differences of this pattern. Right? Now, 2.2.4. How many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060. So remember what I told you about the previous question always leads into the next question, and that's exactly what's happening here. We found this equation and we're going to end up using it. Okay, so if you look here, we've got 6n squared plus 3n, right? And here they got minus 3 plus Sn is equal to 21,060. So why did they say this? Well, let's take a look at the question. How many consecutive first differences were added to the first term? So there they state that, right? So if I just highlight this information, this is, let me just pop this open. I just want to get a bolder marker. There we go. This is the first term that they state, right? They say how many consecutive first differences were added to the first term. What was the first term? -3. They're asking how many consecutive first differences. This equation that we found represents the consecutive first differences, right? We can call this the consecutive first differences, right? Of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060. So all they said was -3 plus Sn, which is this, is equal to 21,060. And we go here to the memo. And we just clear this off. Here we go. And if we look here, that's exactly what they did. And then they said Sn then equals 21,063. They then substituted what Sn is equal to, which is 6n squared plus 3n. And then we get this. And then we're going to solve for the n value. So they do this over here. They move that over. They remove the common factor of 3. And we get 2n squared plus n minus 7021. Of course, this is going to be very hard to try to factorize by yourself, and you'll find that you actually won't be able to. So all you do is you use the quadratic formula. And there they go, n equals minus b plus minus the square root of b squared minus 4ac over 2a. And they input the values, substituting what b is and what a is and what c is. They substitute it into the formula. We know that a is 2, we know that b is 1, and we know that c is 7,021. Then we find that n is equal to 59, or n is equal to -119 over 2. So here's the interesting thing. We cannot, the term number cannot be negative.
Muntasir?
Yes?
Seem to be experiencing a little bit of technical.
I'm hearing you breaking up, yes.
Oh, can you hear me?
I'm hearing you, but you were breaking up for a moment
Well,
there.
breaking up for a period there. I think something must have happened in the system. I think it's rectified now, so you can continue after that interference.
No problem, it's fine, it's fine. Okay. So as we continue, we'll see that the nth term is the 59th term. So we find that the 59th term will give us this value of 21,063, right? And that is going to be our answer. It's really, really as simple as that. Not too hard at all. Now, let us go on to the next question. So, let me just zoom out. You can see the full question. So here they state that consider the quadratic number pattern. Okay, so here we go again. Now let's just copy this out. I just want to crop it out and add it to a new page quickly. Let me do this. Add it to a new page. And let's take a look. There we go. So, consider this quadratic number. Write down the value of T4, so the fourth term. Okay, this is fairly easy. So we'll go 3.1. And we write down our sequence -145, -122, -101, and we need to find this fourth term. We'll call it x. Now, Step 1, remember they tell us it's a quadratic number pattern. So what do? Find the first difference first. Okay, so what's the first difference? So we say negative 122 minus negative 145 is going to give us a value of 23. Then we find it for these, between these two terms, between the third term and the second term. And I'll just put this on top here so you know what I'm talking about. This is the first term. This is the second term. This is the third term. And this is the fourth term. Now we go ahead and we find it. Negative 101 minus 1 minus negative 122. And this is 21. Okay. So now we just need to find the second difference. And remember, the second difference is repetitive and constant for any quadratic number pattern. So therefore, this is going to be 21 minus 3, negative 2. So that's our second difference. Okay. So therefore, what does that mean? Okay. Now we need to go ahead and use this second difference to find the rest of the first differences. So therefore, what would then the first difference be over here? Well, it's fairly simple. If we take a look, the difference here is negative 2. So therefore, the next second difference is going to be over here, which is also negative 2. Right? So we've got this and this, got this and this, we got this and this. So we know this is x plus 101. And the reason I say that is because it's x minus negative 101. And that's why it becomes plus. So then the difference over here is supposed to be negative 2 as well. So now we can solve for the fourth term, which we called x. So now I can just say, well, if that's the case, we can then say that negative 2 is equal to x plus 101 minus 21. So now we can just solve for this. This is going to be negative 2 is equal to x. What's 101 minus 21? Let's take a look. That's 80. All right, so this is plus 80. We then move the 80 over and we find that x is equal to what? Negative 82. There we go. And negative 82 is our value of x. Now let's see if we are correct according to the memo. Let's take a look. All right, so our fourth term is supposed to be negative 82. Let's see. I'll go here. We solve that one. And there we go. Negative 82. Easy peasy lemon squeezy. Right, so not a problem at all. Now we need to go on to question 3.2. Let's take a look. 3.2. Show that the general term of this number pattern is tn minus n squared plus 26n minus 170. So we go back here. Here we go. All right. So we've solved that. So let us first just substitute these values in that we have found. So I can go here and I can quickly erase this. And I can write over here that this is negative 82. I can then go ahead and change this over here. It's supposed to be negative 82 plus 101. That's a 19, which also it correlates with everything that we found. All right. This is 19. And there we go. All right. So we have our sequence all set up. So now, remember, I told you that this is A plus B plus C. This is 3A plus B. And this is 2A. Right? So let's erase this. And we can go ahead and solve 3.2 with all this information filled in. So show that this is the general term for the sequence. So first we solve for A. So 2A is equal to negative 2. And we can say therefore A is equal to negative 1. Now we use 3A plus B. We know 3A plus B is equal to 23. Okay. We can substitute the negative 1 in over there, so we'll get negative 3 plus b equals 23. And we can say, therefore, b is equal to, we move the 3 over, 26. And then we can go a plus b plus c is equal to this value over here, negative 145. Substitute our variables in. Negative 1 plus 26 plus c equals negative 145. Therefore, c is equal to, and if I just shift everything over, negative 145 minus 26 plus 1, and we find that c is equal to negative 170. And all we do is we just now substitute this in to the general formula for a quadratic equation. So what's the general formula for a quadratic equation? Well, if you remember, it's the same for your quadratic functions as well. Ax squared plus bx plus c, or in this case, because we're using an nth term, we can just say that tn is equal to an squared plus bn plus c. We then substitute our values in. So this is going to be, where a is negative 1, this is negative n squared, b is 26 plus 26n, and c is negative 170. And there we go. We have solved for the general term. Let's see if we are correct. I'll go here, open this up, and there we go. Minus n squared plus 26n minus 170. And that's a full 3 marks for all those calculations. Okay. Now, 3.3. Between which two terms, so let me just highlight some important points so we don't miss anything out. So which two terms of the quadratic number pattern will there be a difference of negative 121? Right, so they want us to find out between which two terms there will be a difference of negative 121. So what I'll do is, let me just put this on a new page. We go to desktop. We'll go over here. Is it this over here? That's correct. Where's this now? Yeah, there we go. Just add this to a new page so we can have some more space. Okay. Right. So, between which two terms of the quadratic number pattern will there be a difference of negative 121? So, they're of course speaking about the first difference here. Right? Because we know our second difference is a constant value of, if we go back here, was a constant value of negative 2. Okay. So, negative 121. So, we can see that our first difference is decreasing, right, in increments of negative 2. So somewhere along the line, this is going to be really, really, really tiny, and there's going to be some term over here. Okay, now let us take a look. So we'll just go here to the memo, see what they did. And if we take a look here, they say that Tn is equal to Bn plus C. Or, if you prefer, we can just use this formula over here, because what we say, this is essentially the arithmetic formula, right? And this is going to assist us, because why? So normally we use quadratic formula for quadratic sequences, but what are we speaking about here? We are actually speaking about the pattern related to the first differences over here. And the pattern for the first differences is an arithmetic sequence. So we're going to use the equation for an arithmetic sequence. And that's exactly what they did over here. They used the equation for an arithmetic sequence. So that's a thing you can identify in these questions, right? If they ask you to identify things strictly related to the first differences and they're ignoring the terms in the beginning for the quadratic sequence, and you can go ahead and jump straight to an arithmetic sequence equation like this. So then we can say Tn equals A plus n minus 1d. Now, if you notice, they're using A equals 23. And if we go back here, let's just check something, and we'll see here, look, the first term for our first differences is 23. Okay? So we can take a look at that, and we'll go back here. So that's what they did. They used 23. They got plus n minus 1, bracket minus 2. And we know the difference between the first differences is going to be negative 2. So if it helps, you can just do this. You can go ahead. All right, we'll go here to this page, and you can just write down the sequence over here, 23, 21, 19. Right? So I'll go here. Oops, go back here. And for 3.3, just to make it a little bit clearer, let me just recall this, 23, 21, 19. So we've got 23, 21, and 19. Right, so now it looks a little bit clearer what we're speaking about. Right, and this is negative 2 and negative 2. Now this will carry on infinitesimally until we get to negative 121, right? And then it'll carry on from there over and over again, because that's what a sequence does. Okay, now then they went ahead and they selected, because this here is just an arithmetic sequence, they selected this formula, Tn equals a plus n, I believe it's 2n minus 1d. Let me just double check. No, just n minus 1d. All right. Okay, substitute this first term, which is 23. Okay. N minus 1. And the difference is negative 2. Okay, that's what they did over here. And then you'll end up with Tn is equal to 25 minus 2n. So what do we do from there once we have this equation? Well, we take it, right, like they did over here. They got the same formula. And then we state that, well, they asked us with regards to, if you look over here, I'll just go back here. They asked us about the value negative 121. So we know that the Tn term is going to be negative 121. So we can just write this over here. Well, if that's the case, then negative 121 is equal to 23 plus n minus 1 minus 2. We're going to get negative 121 is equal to 23. And we're going to expand this. We're going to get minus 2n plus 2. And then if we solve for this, we'll get this value over here. So we just go back here. And then they solve for it, and we get that n is equal to 73. So then we can state that this difference value exists between 73 and 74. That's it. Right? As simple as this. So why do they say between 73 and 74? Well, remember, if you're finding a difference, and they want to know between what two terms, right? And the difference will exist between the higher term and the smaller term. So between 74 and 73, there's a difference of negative 121. Now, for the final question, 3.4. What value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1? The maximum value. Oh, sorry, the value of the maximum term in the new number pattern formed will be 1. So how do they go about solving this problem? Let us take a look. So here they just went n equals minus b over 2a. Now, doesn't this look rather familiar? You've seen this equation somewhere before when you're trying to find the turning point of a quadratic function, which is normally, you'll state that the x-coordinate is minus b over 2a. And that makes sense if you think about it, because they're talking about a maximum term. Now, for this specific function, if we look at it, the original function, I'll scroll up. Look at this. It's negative n squared plus 26n minus 70. Now, if you know your functions, and I'm going a little bit off topic, but if you know your functions, if this a value over here, this negative is telling you about the shape of your graph. And they're telling us that this graph is essentially shaped like this. It's a sad face. Okay, this is just a rough sketch. But look here, this point here, which is your turning point on the function, is your maximum point. That's your maximum. Where your x value is here, which is your turning point, it's going to tell us what the coordinates are, x, y. So if we find the x value, right, which is the maximum value, and it's found by using this equation, x equals minus b over 2a, we will be able to find the x coordinate of that maximum value. Right? And if we go back to this question here, let's just go back here. I'll delete this, clear that off. They state that what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1. Okay, lovely. So we go ahead and we see that they used minus b over 2a. So they substituted b, which is negative 26. Where did that negative 26 come from? Well, let's take a look. That negative 26 came from this equation over here, right, which we found, right? So these are b value, 26. So b is equal to negative 26. So we go back here. Here we go. And they use negative 26. The a value is 1, right? How do we know it's 1? Because they told us, right, that the maximum term in the new number pattern formed will be 1. They're telling us that over there. So it's exactly what they did. So they substituted a as 1, which was the new first term in the sequence. And you find that n is equal to 13. So therefore, we can say term 13 is equal to negative 1. That's what they stated over there. And then they say, therefore, add 2. So term 13 is equal to negative 1. And as simple as that. That's how you solve it, right? And where did we get this negative 1 from if we found that n is equal to 13? Well, if we go back to the original equation that we solved for, so if n is equal to 13 and we substitute it into here, let's see, we are negative 13 to the power of 2. So it's negative, it's minus 13 squared, to the power of 2, plus 26 times negative 13 minus 170. And that's actually not working out correctly. Hold on, did I do something wrong here? That is correct. Times negative 13 minus 507. Something odd. Why is this not working out? Oops. Let me just see. So give me a second. I'm just busy on my calculator. Oh, there we go. Okay. That makes more sense. Right. So yeah, if you just do that substitution, you'll get to a value of negative 1. So here they say term 13 equals negative 1. And yeah, that's how you go about solving it. So you'll get the value of 13. You'll say term 13 equals negative 1 for this over here. Sorry, the negative 1 comes from this formula over here, where we derived this from the arithmetic sequence. You substitute negative 13 into here, you will end up getting positive 26. No, you just substitute 13 in here, not negative 13. You substitute 13 into here, you'll get negative 26 plus 25 gives us negative 1. And then they say, therefore, you have to add a value of 2 to get that answer. All right, and if we scroll up, so where was that sequence? Let me just go back to the original image. And plus 2. Yeah, that's correct. So we add 2 and then we get negative 1. And that's it. That's how we go about solving this problem. Right? So if you do need any further assistance, or you do want the memo, you want to go through these questions by yourself as well, they are available on the website. Okay, so you can go to www.intunetutoring.co.za. There will be a Voice of the Cape link on the web page. In fact, I think the link will be given to you. And yeah, and you can go ahead and download these documents and use them yourself. So there we go. That's it for number patterns. And then we'll be looking further into sequences and series for the next math session. So yeah, that will conclude our session for today. I hope this helped you somewhat with number patterns, and enjoy the rest of your day. Assalamu alaikum wa rahmatullahi wa barakatuh.
Shukran so much, Muntasir. Really, really appreciate it. I think a lot of people learned from that. I'm sure I will put the link that you described there in the description of this video. So if anybody wants to check that out or wants to get those notes, I can check there. But Muntasir, once again, shukran so much for availing yourself. It's really, really delightful to have you on board with your expertise. I think I had a few flashbacks while you were talking to my matric days and remembers the horrors that was number patterns and me sitting there trying to figure it out. Kind of understood about 50% of what you said. So alhamdulillah, even I learned something that I forgot. So shukran so much. Enjoy the rest of your day. I hope it will be fantastic. Assalamu alaikum.
Wa alaikum salam. Shukran so much for having me.
No problem. And so I go to all of the viewers that have been watching this. That's the conclusion for the day. Tune in tomorrow, same time, same place, for more of the Matric Revision Program. Salam.
Salam alaikum.